Hello, welcome to episode 2 of live.withcode.uk. In this season, we are looking at how to prepare for the more challenging questions in Edexcel GCSE Computer Science, the Paper 2 Python test, but also building up your familiarity with turtle graphics and having a little bit of fun looking at how the theory links in with the practical programming. So in last week's episode, we looked at the basics of drawing abstract shapes and graphics just using circles and filling them in. So we made this turtle. We're going to go a stage further today and look at how we can, rather than using vector shapes just made out of circles, how we can define each pixel and then display pixels using turtle graphics. Last week, I made this image in Inkscape and exported it. So the starting point is to use this tool, tools.withcode.uk/bitmap. Choose any picture you like. I'm using this picture of a turtle called Bob by my students. We're going to stick with just black and white. Maybe we'll do colour images next week. That will involve a three-dimensional array, which is more complicated than you need for GCSE. But this two-dimensional array, 2 dimensions because it goes across and it goes down, stores 32 by 32 pixels. That's quite a lot of pixels. We could change the threshold if we wanted, but the default value is reasonable for Bob the turtle, so I'm going to stick with that. All right, so we get the bitmap data. If we copy this into Create with Code, what we had before, it should display it as a bitmap image. But I want to know how you can process this using turtle graphics. How can we manipulate a two-dimensional data structure and display it using turtle graphics? So I'm going to get rid of all of this stuff with the built-in with code module, and instead let's use turtle graphics. So import turtle. We should probably have the same kind of structure as Edexcel likes us to use. So here we go, modules, import turtle. We should have some global variables. And this is the bitmap data. Now this is going to be a nightmare for you if you do the type race. Sorry about that, it might take a little bit of doing. We could put it in an external file, maybe we'll do that next week. We're probably going to need some subprograms because I want to be able to draw each pixel separately. So I would like to define a subprogram, just create some space so it's not right at the bottom of the screen, called draw pixel. Oops, can't spell. I need to know where on the screen it is horizontally, the x coordinate, where it is vertically, the y coordinate, and a parameter for the color. So that's what the P stands for here. You don't need a P here for Python, but Edexcel always tends to put a P here to represent the fact that this is a parameter. And it's going to be something to do with turtle to move forwards now. We could do circular pixels or we could do rectangular pixels or square pixels. I'm going to go for square pixels, so that will involve moving forwards a certain amount. How big is each pixel going to be? Don't know, but that sounds like the job of a constant, as in something that doesn't change when the program runs, but is a value with a name that we can change at code time, not at run time. So pixel size, let's say each pixel is going to be 5 actual pixels. What do I mean by that? Each square represented by a number in this data here on the actual screen is going to be 5 pixels by 5 pixels. Right, so now we can use that here. That's the constant we've defined at the top. To draw a square, we need to move forwards and turn right by 90 degrees. We could go left, it doesn't matter, as long as we do the forwards and the turning 4 times. So let's indent both of these. When we run it, there's no errors, but nothing happens because we've defined a subprogram. We haven't actually called it yet. We haven't made it happen. So let's have the main program down here. Main program. And to test, let's just go draw pixel. Now this is probably going to fail to begin with, but it would be nice if I can have 0 or 1 to draw either a black or a white pixel. Now, we're trying to use a global variable called t, which we haven't defined yet. So we'd better make a global variable called t, or Bob, I suppose we could call it. T equals, we go inside the turtle module, we create a new turtle object. Lots of people forget to put these brackets on the end, but they are essential. And we've drawn one pixel. It's not coloured in yet, because our draw pixel doesn't actually do that. So let's see, t.color, spelt the American way, because it's built into that turtle object. What colour? Well, that's the parameter that we've received. We want to use this here. We want to begin filling in, actually draw the pixel, and then when we finish drawing it, that's why I pressed backspace to unindent, and fill. So that will do it in 0. How about specifying, what will it work in? Yellow? Yeah, well, will it work in black or white, presumably? I guess what I want to do is iterate through all of this, and if it's 0, display it in one colour. If it's 1, display it in another colour. Right. So for x in range, now you're going to need to do this for all 32 pixels, but waiting for them all to display is going to take ages. So I'm just going to test it with 5 by 5. For y in range 5. Now this is a nested loop. We'll have every y value for every x value. So this line here is going to be repeated 5 times 5, 25 times. So if I put x and y in here, I can put a different color in here. Now this means I should find out what value it is. So if, what's the name of all of this data, which is called data? I've got two indexing expressions, x and y, or y and x. Which way round is it? Well, how do we know? The first indexing expression is going to be which line of this two-dimensional list it's going to be. So that will be the 0th line. And then the next indexing expression will be how far along that particular line we want. So the first one is y, the second one is x. So if that is equal to 0, then, I don't know which way around it is, we'll have to do trial and error. Otherwise, we can draw in white. Will it work? Don't really know. There's only one way to find out. So kind of, however, all of our pixels take up 5 pixels on the actual screen, and we're drawing them all in exactly the same place. And we're waiting ages for all 25 of them to display. So that's a bit irritating. How can we fix it? Oh dear, it's not recovered all of the code, is that right? Yeah, there we go. Yeah, we haven't actually teleported to where we want to go. T.pen up before we teleport, T.pen down after we've teleported. We should probably comment to say move to the right place. Oops. And draw a pixel in the right color. Oops, there we go. T.go to, these are the coordinates that we need. Now be careful here because this is not in the right place. In fact, I'll speed it up so it tries to draw it a bit faster and we won't get quite as bored waiting for it. So they're not all in the same place now, but they overlap. They're not in the grid where we want them to be. That's because we need to multiply this by the actual size of each pixel. Because each pixel for us is 5 actual screen pixels. There we go. So this should draw 25 squares. Some of them should be white and some of them should be black. Will it work if we go all the way up to 32 by 32? Possibly. I mean, the turtle is probably going to be the wrong way round. You might have to try and work out how to deal with that. But it looks like it's iterating through a two-dimensional data structure. It's calling a subprogram for each value, depending on what the value in that two-dimensional data structure is. So I'm going to leave that running. I thought of some challenges for you to work on. So I'm just going to copy these down here. Help, there we go. Plop these at the bottom. So first challenge, can you flip the turtle so it's not upside down? Can you make it so it's red and white rather than black and white? And can you speed up the drawing? It seems a bit unnecessary to draw a white square Can you just get rid of that else and that line in here? Will that work? All right, those are your challenges. I hope this has been helpful. Next week, we're going to work with a colour image rather than a black and white one. In the real world, you would never use Turtle graphics for something that actually displays. This is purely for educational benefit, to try and teach you what goes on behind the scenes in a graphics engine. It is not optimized for speed, as you can tell. All right, all the best. See you next time.